Good evening, students. This is Tuhin sir again, and today we are going to start friction in an inclined plane. I am not going to discuss basic inclined plane here, assuming that you know that as you can see, there is a block of mass m kept on an inclined plane. If an mg acts down, if I were to break it into components, then mg sine theta would be acting down the plane, which would be accelerating the block of mass down the plane, and a friction force would oppose this motion as far as long as possible. And friction force and the normal force here, as opposed to a body kept on a smooth horizontal surface, would not be mg, it would be equal to mg cos theta, which would be the normal reaction force. And that is because you expect the body not to move like this up and down, and here in an inclined plane what happens is you take this as the y-axis and this as the x-axis. So along y-axis you don't expect the body, if it were to move down or maybe even up in some cases if there is a force acting upward, so there will be no vertical motion in the y direction. So normal force would be equal to mg cos theta, and the friction limiting would be mu n, as we have discussed in the earlier videos, and that would be equal to mu mg cos theta. Now, before we dig deep into what friction in an inclined plane problems, let us first understand what is angle of repose. Repose means to rest. And what is angle of repose? Many of you, the students, would be knowing this, but still I am going through this. And an angle of repose is the maximum angle theta. Let us say I start from here. This is the inclined plane. This is the inclined plane. Okay, and I keep a mass here. And mg sine theta downward, friction force upward, and this surface is rough, so I have given a coefficient of friction mu. If the body is at rest, the friction force upward is equal to mg sine theta downward, and therefore the body is at rest. And now if I keep on increasing the angle until I reach an angle beyond which, if I increase it by even 0.1 degree, the body would no longer be at rest, and that particular angle beyond which any increase in angle the body would no longer be at rest is called the angle of repose. So for angle of repose, when the angle of repose is reached, a limiting friction force would apply up the plane so as to oppose relative motion that we have already discussed in my earlier lectures. So that is the angle, that is the time when the maximum limiting friction static friction would apply up the plane. And what would happen? Down the plane we have got mg sine theta, which is down the plane. Up the plane we have got mu n, which is mu mg cos theta. Cancel out mg from both sides, so you have at angle of repose tan theta is equal to mu. As I had told in my earlier videos, we are going to discuss one joint entrance problem every week, and today we are going to discuss a problem from DC content. And what is the question? The question says a block rests on a rough horizontal inclined plane of angle 30 degree. Okay, let us say this is the mass. The coefficient of friction, and we assume here the coefficient of friction is the static coefficient of friction, which is given as 0.8. And the question is, if frictional force small f is equal to 10 Newton, find the mass of the block. Now these are exactly the questions where a lot of students may get confused and start using mu is equal to 0.8. Remember that the limiting friction is only applied, just as I told just a few minutes back, when the body is about to make relative motion with the surface in contact. In this question, the body is at rest at that particular angle, which is 30 degree. We do not know whether it's the angle of repose. If it had been the angle of repose, the limiting friction would have acted upwards, which would have been F limiting, which would have been mu, which is 0.8 into mg cos theta. Since we don't have any information whether 30 degree is the angle of repose, we should not get caught in such problems. The body is at rest, fine. We have been asked to find out the mass of the block. So simple, just don't go into mu, use the mu straight away. What you have to do is that the friction force is equal to 10 Newton upward of the plane. As we have discussed, mg sin theta is down the plane, and for the body to be at rest, the forces up and down the plane have to be equal, which means the body is at equilibrium. So m, and we are taking g as 10, g sin 30 is half, is equal to 10. Mass is equal to 2 kilogram. That is the answer. If instead we had gone into the use of 0.8, we would have had to do, because the entire 0.8 is not used, we would have had to do mg sin theta is equal to what fraction of this 0.8 is used, so that mu, or rather here mu used into mg cos theta. So mg cuts out, so tan theta is equal to mu used. Tan theta would have been 1 by root 3 because it's 30 degree, and mu used would have been found out. So this is another question which, while solving this, just came to my mind that okay, if you are required to find out what is the mu that have been used in this particular example, then you will use this particular thing. So students, I hope I have been able to make you understand this question, how to wisely use the mu, when to use the mu, when not to use the mu, so that you don't get caught up in these questions. And I hope if you have seen the video, and if you have liked the video, please don't forget to click the like and the subscribe button, which will encourage me to create more and more videos. And all these videos that I'll be creating, I have started with friction, move on to other topics, and we will be dealing with all the joint entrance problems in all the chapters that I will be making videos on. So thank you for watching.